Welcome to your last lesson of the week. We are going to be talking about classifying real numbers, so make sure you've got all your materials out and ready to take notes so we can get started. So the first thing, as you can imagine, we want to do is to define what real numbers are. Now, real numbers are all numbers that are on the number line. So you've seen a number line in many of your classes before, and real numbers encompass all those numbers that are on the line. So what I like to draw when we first start talking about real numbers is this circle here. And the idea that real numbers is the big circle here. And then inside of it are all the other types of numbers you've learned about. So on that number line, you saw whole numbers like 1 and 6. You saw integers like 0 and -4. You maybe didn't see them labeled, maybe you did, but you certainly saw some fractions like 1/2 or other rational numbers like 0.7. Those were on the number line. And then you saw the irrational numbers. So that would be the ones that are still real, but don't fit into any of these other categories that we've seen before. We talked about pi is an irrational number, or maybe the square root of 14. Those would be good examples. Now, if there's real numbers, there are also imaginary numbers, and students like to make up their own weird definitions of imaginary. But in math, it actually has a very specific definition, and these are the square roots of negative numbers. So this would contain like the square root of -14. And they're not real, they don't overlap, but they're still there. They are types of numbers that you will eventually know how to use very well. So the first thing that you're going to want to do with your new sets of numbers is we want to make sure that we can classify them, meaning that we're going to put them into their appropriate group. So here we've got a list of 8 different numbers, and we are going to put them into these categories. Are they whole numbers, integers, rational, irrational, real, or imaginary? And my advice, the first thing we always want to do is simplify. So for example, if I look at A, it's got roots, it's got fractions, it's got all these things. However, if we simplify first, the square root of 9 is 3. 3 over 3 is 1. So A is a whole number. It's the first whole number. This is A. Now, what I always will do is find the smallest circle that this will fit into. So for example, this is a whole number, which means it also is all of these. So A is a whole number, which means that it is also an integer, it's rational, and it's real. Okay. The next one we're looking at is B, -3 and 6.6 repeating. So whenever you see a decimal with the bar over it, that's repeating. This means that it is a rational decimal. Any decimal that ends or repeats is rational. The ones that are irrational are ones like pi, where they go on forever, but they don't repeat. So if I see repeating, I will know, oh, that's rational. So it's a rational, and if it's rational, it's also real. C, again, we've got a root, we've got negatives, maybe it's imaginary, but we're going to simplify first. And -3 times -1 is a +3. So this is root 3. Since 3 isn't a perfect square, it is irrational, but that means it's also real. D, again, we've got a root, but we can simplify, and we end up with 1 over the square root of 9, again, which is 3. So we have a fraction, meaning it's rational, which means it's also real. E is the square root of 3. We've seen this already, so C going with that. Negative root 9 simplifies to -3. So we are going to say, well, that's not a whole number because whole numbers aren't negative. but it is an integer. That's the first of this set here that it fits into. So we have an integer for f, which means it's also rational and it's also real. G is our first square root of a negative, which means that's our only imaginary number. Now, H is a little tricky, and this is one of the ones that my students tend to not believe me on, but this simplifies 0.9 repeating to 1. I know, it feels strange, but the reason for this is, if you remember from earlier, 0.3 repeating is equal to 1/3. Well, 0.9 repeating would be 3 times more than that, so we just multiply both sides by 3. So now we have 0.9 repeating on this side and 3/3 over here. Oh my goodness, well 3/3 is equal to 1. So we've already seen 1 in this case. It was A, which is a whole number. So there's H, which means it's an integer, which means it's rational, which means it's real. Another thing you will be asked to do in this lesson is find a real number between two other numbers. So in this case, 0.45 and 7/9. Now, one way to go about doing this is to plot them on the number line. So here we have our number line. I've drawn in 0.45 here, and then I've colored in, using our inequality, all the numbers that could work for answers, right? Because that's the goal when we're graphing an inequality. We color in all the numbers that could work, and then we stop, in this case, at 7/9. So once you've graphed it out, it's easy to say, oh, well, it goes here, here, here. Anything could fit in. You could have 0.5, you could have 0.6, you could have 2/3. These all fit. But sometimes the fact that there are infinite possible answers makes students feel really uncomfortable, because then they have to pick one of this infinite number of answers. That can be really overwhelming. So one thing that you can also do if you find that overwhelming is you can just find the average, meaning you add them together and divide by 2. It won't always be necessary, but it will always work. So in this case, I'm going to add them together. So 0.45 plus 7/9, and we'll end up dividing by 2 since we're finding the average of two numbers. In order to add these together, I'm going to write them both as fractions. So 45 over 100 plus 7/9. And I will find a common factor, not a common factor, a common multiple for my common denominator, which in this case, you could just multiply them together if you like. So times 9 times 100. And I'm going to turn my division into a multiplication by the reciprocal. So this was 2 over 1. So this is times 1/2. Now, we're going to finish our work over here. We now have 405 over 900 plus 700 over 900 times 1/2. So that would be, in the numerator, we just add those together. 1,105 over 900 times 2. And I'm going to simplify by 5 in both the numerator and the denominator. And so we end up with 221 divided by 900 divided by 5 is 180 times 2. So my final answer would be 221 over 360. Now, finding the average, again, is not always necessary, but it will always work. Let me know if you have any questions by putting something in the comments, scheduling a Zoom meeting, and nominating problems in the form attached. I'll talk to you later.